All right, another example when you will get one triangle is this situation here. So again, for those of you like to do that little test, I will go ahead and put this here. So my angle with the side across from it, and here's my other side. And so again, if you really want to do that little height or altitude, I'm going to stick that in there. And so you get the sine of 36.87 equals what? H over 5. And if you cross multiply here, you end up getting H equals, and when you round, there's a little bit of rounding here, but it should be 3. And so when you look at that, you're like, well, this side equals 3. Well, basically what that tells you then is that that side cannot come out at any type of angle. Now, it's not too short, so it's not 2 where it's not too short. It's not, say, 4 where it could swing out or swing in. It's not 7 where it has to be out, and if it swung around, it would be outside the shape. It's not any of those situations. Basically, what's happening here is it's 3. So what that's telling you is that you actually have a right triangle, and it's exactly the same as the length of this side over here. And so you're still only going to get one triangle because of that. Now again, I typically don't do that, so I would just do off signs. So 36.87 over 3. Let's see, my B is right here. C is there. Here's my A. And then here's the little side C. All right, so then I have what? Sine of B. And I have sine of C over C. So again, I would cross multiply like we've been doing. So multiply those and divide by 3. And I end up getting that the sine of B equals 1. Now again, it should be perfectly 1, but again, your calculator might give you 1.000 some change, but it's supposed to be exactly 1. Do the inverse sine to both sides. Those cancel, so angle B is a 90-degree angle, which again, since I tested earlier, I predicted, but again, if I didn't do that, that would be totally fine if I just did it my normal way. All right, so to get angle C, I have 180 degrees. I've used up 36.87, and I've used up 90. Now again, this time, because you have a right angle here, you could just subtract from 90, which, you know, might be faster. So 53.13 degrees, it's angle C. All right, and then to get this other side, I would fill in the stuff that I just figured out. All right, so I know that angle B is 90 degrees. I know that angle C is what, 53.13 degrees. And I need to figure out C. Now, normally I'd probably go back over here, but since I know this is 1, that makes my math a little easier. So I'm going to multiply those, and I'm going to end up dividing by 1, because sine of 90 is 1. And so when you do that, you actually get that C is, and again, it might look like you have to round, but it's actually, should be an exact answer there, that it's 4, because this is a 3, 4, 5 triangle right here, and so that makes sense. Now, if you're like me and you're like, okay, so is there another triangle? I go back to my inverse step. So right here, when I had sine of B equals 1, and I did inverse sine, I know that typically my calculator gives me one answer when in reality there's 2. But if you look at this problem, there's only one value on the unit circle where the sine is 1, and that's at a right angle at 90 degrees. Usually we reflect over on these other problems we're doing, but this would just reflect onto itself. So this is a unique answer. There's no other answer, and so therefore there's not another triangle. So I can just look at that and I can say, okay, there's only one triangle, and those are my values.